Good morning, everybody. Welcome to the second day of GSE, the virtual. My name is Jeff Eggleston. I work for IBM. I'm in the hardware division, and I am chairing this wonderful session with Anna Chagall from IBM. Just a few house rules. We would actually encourage questions during the presentation. So if you can put them on the chat line, then basically Anna was quite happy to take them. And without saying anything else, I'm going to hand over to Anna on machine learning acceleration on the z16 with SnapML. Anna, over to you.
Thanks, Jeff. Good morning, everyone. I'm Anna Chagall. I work for the worldwide team, helping clients all over the world with containerization, modernization of their platform. In this session, I'm going to take you through the machine learning library that is available on IBM Z platform. It is called SnapML, Snap Machine Learning, and together we're going to go through a demo where I'm going to be using this library for classifying Bitcoin transactions. So if you do have any questions, please don't hesitate to ask. And with that, let's start. Machine learning and data and AI, they're a very hot topic right now. Almost every business wants to infuse AI into their applications. You must have heard about popular AI frameworks such as ChatGPT. So in this session, I will introduce the capabilities that are available on IBM Z platform, the one that you can use in your shop. In general, in machine learning, there are needs of data scientists such as speed. Everybody wants to train and retrain their machine learning models very fast and make fast decisions based on the outcome. There is also a need for machine learning models to be efficient, accurate, and of course to work with the large data sets, and not being restricted by the data set size. IBM research in Zurich, they have developed SnapML. So this is the library for optimized machine learning. So it can be used for accelerating the training and inference of machine learning models. And it provides implementations of algorithms such as generalized linear models, tree-based models, gradient boosted machines, and it meets the data scientist's needs in terms of being fast, accurate, and highly scalable. For us, for IBM Z professionals, having SnapML on the platform is very important because we can run machine learning algorithm on Z and use the acceleration which is provided by both SnapML and SnapML can utilize the new AI accelerator, which is available on Z16 platform. So basically, using the combination of those two capabilities, SnapML and AIU on Z16, you can train and inference your models on Z in a very fast and accurate manner. You can use pip to install SnapML, and in the demo that I will be showing later today. I will be using SnapML as a part of Cloudpack for Data. Cloudpack for Data is a product from IBM that provides all the services for data scientists. It runs containerized services such as DB2, Watson Studio, Datagate, and many others. SnapML is very good for the following use cases to accelerate machine learning training. So in our scenario, SnapML is using the integrated AI accelerator on z16. It is also accelerating the inference, improves accuracy on tabular data, and it scales to very large data sets, so more than 100 gigabytes inside. And you can try SnapML either on your Linux on Z without anything. You can try it as a part of the Cloudpack for Data. So it's available on all of the platforms, and when it runs on Z, it uses the AI on Z accelerator. The other important feature of SnapML that it is fully compatible with the scikit-learn Python API. Scikit-learn is the very popular framework, very popular ML machine learning framework coming from Python. So here you can see how just with the matter of couple of line codes, you can change from scikit-learn to SnapML, and for the data scientists, such transition is very smooth and doesn't require too much coding. So this was the introduction to SnapML. So the library that we're using for running machine learning algorithm. Let's now take a look at the holistic AI stack that is available on Z. So with the introduction of z16, one of the most important things was the AIU accelerator. So the accelerator that is available on the platform, and it works both for acceleration of the training and for the training and inferencing the models. However, we do recognize that, data scientists, they can train their model on many other platforms of their choice. So the idea was to make sure that the models that have been trained on other platforms, they can run on Z for real-time inferencing. That's why here you can see on the left-hand side, these are the many popular frameworks that data scientists are using for their ML model training: scikit-learn, LightGBM, Python, Jupyter. But then in the middle of the slide, you can see that we can export the models into one of the interchange formats, such as Onyx, PMML, or JSON. And when you're actually saving the models into Onyx format or PMML or JSON, then you can run the model on Z without any changes, without any differences. So if your data scientists, if they're running or training their models anywhere on any other platform, all they need to do is just to export their model into one of the compatible formats, and then you could run the model on Z without, any changes to the model itself. So this is very flexible. This allows to train your models anywhere and then deploy them on Z16 or IBM Z in general. In the demo that I'll be showing you later, I will be exporting the model that we have trained. I will be exporting this on Onyx format, and then I will be deploying this on IBM Z. You must have heard about the AI integrated accelerator on Z16. This is a really important milestone for everyone. So on the right-hand side, you can see how the AIU accelerator is functioning. Basically, it is present on every chip module. It is being shared by all the cores, and what it does, it accelerates the certain operations which are, for example, like matrix multiply, matrix convolution, which are used by the data scientists by their ML or AI applications. Are there any questions at this moment?
Anna, there are no questions in the chat line at the moment.
All right, thank you.
Okay.
Perfect. So here you can see the performance benchmark. So there was a data set that came from the ML competition a couple of years, sourced by the Santander Bank. They were using XGB Boost, and they were using SnapML on Z16, and you can see how fast they can run. They can run 525,000 in reference with a 1 millisecond of a latency, which really shows how fast you can run your inference on IBM Z. Because if you compare this to, for example, the environment without the AI accelerator, the change will be, the performance will be really different from what you see. So this gives us a very unique position in having the AI accelerator and having the software that can exploit this. So just to give you some of the links where you can start with SnapML. So again, SnapML, it's a free library that was developed for machine learning acceleration from IBM research team. You can just pip install it on your platform, and it works on cross platforms. If you have GPUs, it will try to utilize the GPUs. If you have AI accelerator on Z, it will try to utilize the AI accelerator on Z. And with this, I'm just going to quickly switch to the demo. Sorry, just
I know there are no further questions, just let you know, but everybody who's on, there's 25 participants. I would encourage and welcome questions, and I would say no questions stupid. So please, any questions or any comments, Anna would welcome them. So
yeah, absolutely. Sorry, Jeff, can you help me? What do you see right now on my screen? Do you see an accelerated Z16 inference?
Absolutely, it's on my screen. I'm registered as two because I have a chairman's view and I have a participant's view. And on the participant's view, I do have an accelerated Z16 inference service using SnapML, and I have the code there as well. So,
perfect. So this is the demo time. I was just telling you about the the AI accelerator and the SnapML library. So now it's time to show how it all works. So SnapML is a machine learning library, and in this scenario, we're going to be using the data sets which contain Bitcoin transactions. So you can see I'm getting them from Kaggle. Kaggle, it's a website that provides a lot of data sets for data scientists, and our goal here is to classify those transactions either as licit or illicit. So by illicit, we mean that there are transactions which are used to pay for services, goods, etc. By illicit, it's probably, I don't know, like malware, ransomware, Ponzi schemes, all the bad stuff. So we're going to be using, this is a supervised machine learning. So the data has been already labeled for us. And in this demo, yeah, the goal is to understand. So we have a very large data set of containing Bitcoin transactions, and we need to classify them into good Bitcoin transactions and bad ones. So as for the environment, I'm running on z16. I'm running on z16 with AIU accelerator, which SnapML gonna use very transparently. I don't need to do anything to tell SnapML to use the accelerator. And the environment is actually, it's Cloud Pack for Data running on Z. So Cloud Pack for Data has a lot of containerized services. This is the Jupyter notebook, which runs in Watson Studio. But you don't have to have Cloud Pack for Data to run this. If you have Jupyter notebook, or you can run this, yeah, we can run this with the Jupyter notebook. So here we first start with the importing SnapML and Onyx. Oops. Sorry. Here we start by importing SnapML and Onyx. So we're going to be using Onyx later on to export our model into the Onyx supported format, so we can run it on Z. First of all, we're going to do a lot of data massaging. So we've got the Bitcoin transactions and classes from the Kaggle website. And here we're just going to filter through this data set. We're going to get rid of the data that is not labeled. And then here we're going to see that the here we're going to also do some of the data set breakdown. So we're going to be using part of the data set to train the data, and part of the data set we're going to be using for running the inference later on. So we train the data on the training data set, and then we will be running the model on the remainder of the data set. So here we have run our training, and you can see that according to the data set that we've got, 90% of transactions there, of the Bitcoin transactions, they are illicit, right? So they are good transactions using to buy stuff, pay for services, and around 10% are illicit. So they're probably ransomware, Ponzi schemes, etc. Right now, what we're going to do after we have massaged the data, we have done the classification of the transaction, we're going to train our model and save it in an Onyx format so we can run it on Z. So here you can see the model training time. It took us approximately 15 seconds. The data set is quite big. Here, what we're going to do, we're going to import now our trained model, and we're going to start inferencing. So you can see we have started inferencing. We can change the batch parameters. And here with the SnapML, we're going to calculate the precision, right? How accurate our model is. So we can calculate the precision. And what we're going to do, we're going to compare the precision of our SnapML model with another machine learning framework, which is called scikit-skylearn. So this is what we're doing here.
Anna, we have a question in the chat from
sure.
Adrian. Do you have access to the chat?
Yeah, sure. Sorry, just a moment. Let me take a look. Okay. Yeah, I'm just going to read it out loud. So when it comes to inferencing, is there a time comparison to comparable x86 cloud server? So yeah, I was in the deck. There was a chart that came from the from running the SnapML and SnapML on z16 AIU, and the performance that we were seeing is 500,000 references within 1 millisecond. So on basically without AIU, and it's going to be probably 20 times or even more slower, because the purpose of the integrated accelerator is really to accelerate AI related operations, and unlike x86, the AIU it is shared by all the cores, so you don't have to go through all the cache levels to utilize it. It's not a PCI card like x86 GPUs. So to summarize this, net we're getting the order of magnitude performance acceleration on z16. Of course, we need to bear in mind that we need to make sure that the algorithm and frameworks are supported on z16. But if we talk about popular algorithms such as SnapML and other machine learning, then yeah, you can get a very high performance and throughput on z16 compared to x86 service.
Anna, thank you very much. And Adrian, thank you very much for asking the question. And again, I would encourage more questions.
So by this time, we have trained our model. We have calculated the precision of our model. Basically, it's closer to 1, so it means that the precision is very high. And now we just want to compare this with the inferencing using scikit-skylearn. And here, actually, this might be an answer to your question. You can see here that we've got the same precision, right, using scikit-skylearn. So we compare it to another framework just to make sure that our model is very precise. And here you can see that the SnapML versus scikit-skylearn inference speed up is 13 times higher. So that's what SnapML and ZIU accelerator is. What's what they are providing. They are providing the very high throughput and performance together by utilizing both software and hardware. So this is the end of the demo. We have used SnapML. We have classified the Bitcoin transactions, and we have seen that SnapML runs almost 13 times faster than scikit-skylearn, which is one of the popular machine learning frameworks. With that, sorry, let me just quickly switch back to my presentation. That was our end-to-end inference demos. How to get started with machine learning on IBM Z. It's very easy. So even if you're not running on Z16, you can still get the machine learning acceleration simply from using SnapML. You can use SnapML doesn't require any purchase. You can download it with a pip install and run it in your shop. In the demo, I was using Cloud Pack for Data platform because this is really a platform for data scientists. I run multiple services there, such as DB2 and DB2 Data Warehouse. I run Watson Studio. It's all within a single platform and provides a lot of services, and a lot of more services are coming to IBM Z. With that, I'm just going to pause and ask if there are any questions in the chat from anyone.
I know there are no questions at the moment. And again, if you've got questions or comments, please put them forward.
Yeah, if you have any questions later on, please feel free to reach out and I'll be happy to help. With that, I'm going to give you 30 minutes back. Thank you very much for your attendance. Thank you very much for coming here today. And thanks, Jeff, for hosting this.
So Anna, one of the things is, in terms of your foils that you've given, would you be kind to share them with me? And then what I'll do is I'll put them on the agenda, so anybody that wants them, I'd be very, very grateful if you can share it, so they can share it. And then again, I would actively encourage you to give feedback. This is session 5F. While I've been speaking, I've been madly trying to work out the actual link for it. I'm just about to get it, and I will put it in the chat briefly. So I would actively encourage everybody to basically put some feedback, because it helps us with future presentations for the GSE. So I've just put the link there. I'm going to give it a couple of minutes so you can link that, and then what I'll do is I'll bring this to a close. Oh, and the other thing, as you know, this session was recorded, so the recording will be available. But in order to get the conference recording and the foils, you have to sign on and collect it. So I think what I'm going to do is bring this to a close. I'm going to say thank you, Anna, for attending. I know it's first thing. Did a fantastic presentation, and I really like the idea that you did the presentation with the machine learning and a little bit of a demonstration. So that was really, really good, and it's great to have over 20 participants first thing on the morning. So thank you very much, and I'm going to bring this to a close.
Thank you. Have a good one.
Yeah, cheers.
Cheers.